Well, cast your mind back to February last year and you may remember the excitement when NASA successfully landed its Perseverance rover on Mars.
This crater that you see here was a lake 3.5 billion years ago. So we are looking at the same environment in the same time period.
NASA Mars Rover Perseverance has sent us the most incredible footage of Mars. With its advanced cameras and cutting-edge technology, the rover has taken high-definition 4K images that transport us to the surface of Mars like never before. As it explores the planet's ancient terrain and uncovers new insights, Perseverance offers a stunning visual journey into an alien world, continuing the legacy of its predecessor, the Curiosity Rover, which gave us visuals of Mars in 4K. Both of these are pushing the boundaries of space exploration. So, why is NASA spending billions for a bunch of photos? Well, they're more than visuals. To fully understand the importance of these accomplishments, we need to look at the whole thing from the very beginning. Let's get started. A new look at the Red Planet. Rovers have been instrumental in expanding our understanding of the Red Planet. Over the years, NASA has sent several groundbreaking rovers to Mars, each more advanced than the last, with missions that span over 2 decades. The first major rover, Spirit, was launched in 2003 alongside Opportunity, both tasked with searching for signs of past water. Their discoveries helped solidify the idea that Mars once harbored conditions suitable for life. In 2012, Curiosity revolutionized our understanding by landing in Gale Crater and providing high-resolution images and critical data about the planet's climate, geology, and potential habitability. Then, in 2021, Perseverance arrived, equipped with state-of-the-art technology to search for biosignatures and collect samples for future return missions. Through their lenses, these rovers have offered humanity an unprecedented glimpse of Mars, sending back stunning imagery and helping scientists visualize its diverse landscapes. Let's see how the greatest minds on our planet made all of this possible. The story of the Curiosity Rover. As part of the Mars Science Laboratory mission, NASA's Curiosity Rover was launched from Cape Canaveral on November 26, 2011, marking the beginning of a bold journey that would take it 560 million kilometers or 350 million miles across space to the surface of Mars. On August 6, 2012, after a thrilling entry, descent, and landing sequence, the rover touched down safely on Aeolis Palus, a flat region in Gale Crater near the base of the towering Mount Sharp, which stands at 5.5 kilometers high. From its landing site, Curiosity began its exploration with a singular focus: to investigate the planet's climate, geology, and potential for past microbial life. Gale Crater, chosen for its diverse geological features, was considered an ideal location due to evidence suggesting that water once flowed there. The rover's exploration aims to answer a key question: could Mars have supported life? And more importantly, can it do so in the future? By examining the Martian soil and atmosphere, Curiosity aimed to detect key elements like carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. It also sought to identify features that might indicate biological processes, such as biosignatures or biomolecules. Curiosity was also tasked with analyzing the composition of the Martian surface. This included studying the chemical, isotopic, and mineralogical makeup of rocks and soils, as well as interpreting the geological processes that have shaped Mars's surface. One of the rover's key tools, the ChemCam, used a laser to vaporize small portions of rocks and analyze the resulting plasma to identify chemical compositions, which helped map the history of water and volcanic activity on Mars. The rover also measured the present state of the Martian atmosphere, focusing on the distribution and cycling of water and carbon dioxide. These observations are pivotal for understanding the planet's climate over billions of years, providing insights into its habitability and its shift from a potentially warm and wet world to the dry, cold planet we see today. The data gathered could also aid in future efforts to terraform Mars or prepare for human exploration. Curiosity also carried instruments to study surface radiation. By measuring galactic cosmic rays, solar proton events, and secondary neutrons, the rover provided crucial data for understanding the hazards posed by radiation on the Martian surface. A groundbreaking discovery unfolded in 2013 when the rover discovered evidence of an ancient streambed suggesting that liquid water once flowed through the Gale crater region. The presence of clay minerals, which form in the presence of water, further bolstered the idea that Mars had once had an environment capable of supporting life. Additionally, Curiosity's analysis of the Martian atmosphere, specifically its methane levels, has provided intriguing clues about possible biological or geological processes occurring below the surface. The rover has also reshaped our ability to visualize Mars in ways never before possible. Using its mast cam and other imaging systems, the rover has sent back some of the most iconic images of Mars. The high-resolution images have provided stunning views of Mars's red, rocky terrain, its ancient, weathered landscape, and even its towering mountains and deep valleys. Curiosity's design was based on the successful Mars exploration rover's spirit and opportunity, but with several enhancements. The rover itself is car-sized, weighing nearly 900 kilograms or 2,000 pounds, and standing over 2 meters tall. It is equipped with a suite of 10 scientific instruments, including the ChemCam, the Sample Analysis at Mars or SAM laboratory, and the Radiation Assessment Detector or RAD. The rover can travel up to 90 meters per day on average and has a range of about 20 kilometers. Since its successful landing, Curiosity has exceeded expectations, continuing its exploration long past its initial 2-year mission. In December 2012, the mission was extended indefinitely due to the rover's continued success and its ability to provide invaluable data. Curiosity has been operational on Mars for over 12 years, significantly surpassing its original lifespan. Interestingly, Curiosity was given its name by 12-year-old Clara Ma from Kansas and is powered by a radioisotope thermoelectric generator, a technology proven by earlier NASA missions like the Viking landers in the 1970s. Unlike solar-powered rovers, the generator enables Curiosity to operate continuously, even during Mars's harsh winters and during nighttime when solar power would be unavailable. The heat generated from the decay of plutonium-238 is used to produce electrical power via thermocouples. Over time, as the plutonium fuel decays, the electrical output of the rover has decreased. The generator ensures that Curiosity remains operational, even when environmental conditions on Mars change, as it continues to provide power throughout the mission's life. The radioisotope thermoelectric generator also serves as a heat source for the rover, with waste heat being transferred to systems that regulate Curiosity's internal temperature. The system includes a heat rejection loop with 60 meters or 200 feet of tubing that circulates fluid through the rover, absorbing excess heat and ensuring that its delicate components remain within operational temperature ranges. Moreover, Curiosity's onboard computing system is built to withstand the extreme radiation of space, and it includes 2 identical rover compute element, or RCE units. These computers are tasked with running critical systems and scientific operations on the rover. Each RCE is backed up by a second, redundant system to ensure reliability. In the event of a failure, the backup computer can take over, ensuring continuous operation. In fact, NASA faced a situation in February 2013 where Curiosity's primary computer suffered a flash memory issue, causing it to reboot continuously. After switching to the backup, the rover resumed normal operations. The rover is also equipped with an inertial measurement unit, which provides essential data about its orientation and helps with navigation, making it capable of executing precise movements and maintaining stability across the Martian surface. Curiosity uses both direct communication with Earth via an X-band transmitter and a UHF electrolight radio that communicates with orbiting Mars satellites, such as the Mars Reconnaissance Orbiter and Mars Odyssey. The communication system ensures that Curiosity can maintain a reliable connection to Earth, even though signals take approximately 14 minutes to travel one way. For routine data transfer, Curiosity mainly relies on relay satellites, which have larger antennas and higher power, enabling faster data transfer rates. However, communication with these orbiters is limited to about 8 minutes per day due to their orbital patterns. The analysis strategy for Curiosity's samples on Mars begins with the rover using high-resolution cameras, such as the Mastcam, MAHLI, and MARDI, to identify features of interest on the Martian surface. These cameras, developed by Malin Space Science Systems, provide detailed images at various resolutions. The cameras are equipped with a filter wheel and an autofocus capability, and they store images using lossless compression. If a particular surface is intriguing, Curiosity employs an infrared laser to vaporize a small portion, allowing the rover to analyze the resulting spectra to determine its elemental composition. If the sample is worth further examination, Curiosity uses its robotic arm to position a microscope and an X-ray spectrometer to obtain closer, high-resolution insights into the material. The rover can then drill, collect powdered samples, and analyze them using instruments like the Sample Analysis at Mars, or SAM, and the Chemistry and Mineralogy, or Chi-Min spectrometers. So, what has Curiosity shown us? Well, let's see for ourselves. Visuals from the Red Planet. As the rover descended toward the Martian surface on August 6, 2012, NASA provided a live video stream of the event on NASA TV. The moment was an overwhelming success, attracting millions of viewers worldwide. In fact, NASA's website temporarily crashed due to the sheer volume of traffic as people rushed to witness the historic event. Shortly after Curiosity's successful landing on Mars, the rover sent back its first images to Earth. These initial images offered a view of the Martian landscape shortly after touchdown. The image, taken on August 6, 2012, displayed a close-up view of the surface near the rover's landing site. While the dust cover protecting the camera lens during descent was still partially in place, it provided a rare and raw glimpse into the landscape of Gale Crater. The Martian terrain was barren and rocky, with a reddish-orange hue that defined the characteristic Martian surface. On August 23, 2012, Curiosity captured a striking comparison of images showing Aeolis Mons, also known as Mount Sharp, in Gale Crater. This particular image displayed several versions of the same scene, including raw, natural, and white balance-adjusted color views of the mountain. Aeolis Mons, towering over the rover, presented an intriguing geological feature, with its layers of sedimentary rock revealing clues about Mars' ancient climate and geological history. The raw version of the image gave a direct, unaltered view of the Martian surface, while the color-corrected versions highlighted the subtle variations in the terrain. A month after landing, Curiosity took a stunning self-portrait using its Mars Hand Lens Imager camera on September 7, 2012. The image was a combination of multiple pictures stitched together to show the rover in full view against the backdrop of the Martian landscape. The self-portrait was also color-corrected to reflect the natural hues of Mars, showcasing Curiosity's sturdy wheels and intricate science instruments. It highlighted the rover's size and structure, providing a visual marker of its presence on the Martian surface. On November 26, 2012, Curiosity took another notable image from Rocknest, a location it had visited in Gale Crater. The image showed a sweeping view of the Martian landscape, looking eastward toward Point Lake, with Glenelg visible in the distance. The landscape featured a flat, rocky surface with scattered boulders and fine dust typical of the Martian terrain. Curiosity's camera provided both a white-balanced version of the image for a more accurate color representation and a raw color version, giving viewers a stark contrast between the two. The white-balanced version brought out the red and orange hues of the Martian surface, while the raw version captured the unaltered natural colors. But wait, there's more to this story. Let's unveil the successor to the Curiosity rover. The story of the Perseverance rover. Launched on July 30, 2020 as part of NASA's Mars 2020 mission, the Perseverance rover has been designed to explore Jezero Crater on Mars, an area believed to have once harbored water and potentially microbial life. Perseverance is tasked with analyzing the crater's diverse geology, from its sedimentary deposits to the igneous rocks that tell stories of volcanic activity and water interaction. Building on the success of its predecessor, Curiosity, Perseverance incorporates several upgrades designed to enhance its scientific capabilities. While both rovers share similar body plans, landing systems, and power sources, Perseverance boasts new features such as advanced wheels, an improved robotic arm and sampling system, and MOXIE technology, which can extract oxygen from the Martian atmosphere. Since its arrival on Mars in February 2021, Perseverance has made significant scientific strides, revealing surprising details about the planet's geology, history, and potential for past life. For example, Perseverance's instruments have revealed that the rocks at Wildcat Ridge within Jezero's sedimentary fan deposits likely formed in an ancient lake environment. These rocks are ideal for preserving signs of ancient microbial life due to their continuous interaction with water after formation. Moreover, the Perseverance rover identified multiple types of igneous rock in Jezero crater, suggesting a complex geological history that includes volcanic activity and interactions with water. This finding contrasts with the previous assumption that all rocks in the crater were sedimentary. The rover's radar imager for Mars's subsurface experiment provided detailed images of Mars's subsurface, revealing solid rock and mafic material beneath the surface. It also confirmed that the crater floor underwent erosion before the deposition of the overlying delta strata, further emphasizing Mars's dynamic geological processes. The rover's microphones have also provided insights into the Martian atmosphere by recording sounds of the rover's operations, including the speed of sound and its transmission through the atmosphere. These measurements help scientists understand the composition and density of Mars' atmosphere and the challenges it poses for future missions. In addition to its scientific payload, Perseverance also carried the Ingenuity helicopter to Mars. Ingenuity made its first successful flight on April 19, 2021, becoming the first powered flight on another planet. After completing 72 flights, Ingenuity's final mission in January 2024 ended with damage to its rotor blades upon landing, leading NASA to retire the helicopter. Despite this, Ingenuity's success proved that aerial exploration could become an essential tool for future missions, offering a new dimension to Martian exploration. As Perseverance continues its exploration, the rover's findings promise to deepen our understanding of Mars and its potential for past life. The rover's sample collection efforts are particularly significant, as the samples will eventually be retrieved by a future mission and brought back to Earth for detailed analysis. In the coming years, Perseverance will continue to traverse Jezero crater, conducting detailed geological surveys, collecting additional samples, and testing new technologies. Its discoveries, along with the data provided by other missions like NASA's Artemis program and the Mars Sample Return Initiative, will contribute to humanity's long-term goal of sending astronauts to Mars and establishing a sustainable presence on the Red Planet. By uncovering the ancient past of Mars, Perseverance not only helps us answer the question of whether life ever existed beyond Earth, but also lays the foundation for future missions that will explore the frontiers of human space exploration. The scientific innovations pioneered by Perseverance will shape the future of space exploration for decades to come. The rover's first test drive on Mars, conducted on March 4, 2021, produced the first wheel tracks on the Martian surface. In addition to its exploration, Perseverance is also collecting samples to be returned to Earth as part of the Mars Sample Return mission. The rover had cached several Martian samples, including regolith, rock, and atmospheric samples, for future analysis. The rover's ongoing mission has also led to some exciting discoveries, including the identification of leopard spots on a Martian rock that may provide clues about the planet's potential for hosting life billions of years ago. The Perseverance mission has also inspired people around the world. NASA's Send Your Name to Mars campaign garnered over 10 million names that were etched onto chips on the rover, symbolizing humanity's shared interest in space exploration. The mission also paid tribute to healthcare workers during the COVID-19 pandemic, with a symbolic plate attached to the rover. Additionally, the rover's parachute featured a hidden coded message, "Dare Mighty Things." This phrase has become synonymous with NASA's ambitious goals. Speaking of ambitious goals, we also have fresh visuals from the Red Planet. Fresh visuals from Mars. The Octavia E. Butler landing photo, taken in February 2021, was taken shortly after the Perseverance rover touched down on Mars, specifically during the landing sequence. The smoke plume from the descent stage is visible, marking the rover's safe arrival. It shows the powerful clouds of dust and debris stirred up by the rover's descent, indicating the intensity of the landing. Moving to the view from the rear right hazard avoidance camera, this photo was captured from a camera positioned at the back right of the rover, providing a clear perspective of the terrain that Perseverance had just landed on. It's fascinating because this camera helps the rover avoid any potential obstacles, offering a safe path as it begins its mission. Another captivating image, taken on Sol 213, shows the parachute and the backshell laying on a ridge about 2 kilometers north of where Perseverance now rests. The image provides a striking view of the site, with the rover's location visible amid the ripples of Satar S, which are intriguing geological features of the Jezero crater. The first color photo taken by Perseverance offers a vibrant and clear image of Mars's surface, showing off its reddish terrain, rocks, and dust. This colorized image gives humanity its first true glance at the alien world surrounding the rover, marking an important milestone in the mission. In a panoramic shot taken on Sol 14, we get a sweeping view after Perseverance's first long drive. The image shows the rover's tracks on the surface, offering a sense of scale and showing just how vast and rugged the Martian landscape is. On Sol 44, there's an image taken of one of Perseverance's wheels, showcasing the rover's own footprint on Mars. Then there's an image of the landing ellipse and further tracks of the rover, which visually demonstrates the extent of the rover's journey, starting from its landing spot and continuing through the terrain. Next, we get a glimpse of Mars's ancient history, with an image of an ancient river system surrounding Jezero crater. It shows how the area once had flowing water, giving us a peek into Mars' past, when it may have had water and ancient microbial life. We also have an aerial shot of the rover from the Mars Reconnaissance Orbiter, captured on February 26, 2022. Taken from space, this image gives an impressive overview of the rover's position relative to Mars's surface features, including the Mars formation. Then there are reciprocal photos of Perseverance and Ingenuity, depicting the rover and its helicopter companion as they capture each other in their respective frames. Then there's an image of the Wright brothers field, captured in April 2021. This picture shows us the site of Ingenuity's initial flights, marking the first time controlled flight was achieved on another planet. This is a significant achievement in aerospace history. Then there's the Van Zyl Overlook image from April 2021. It offers a stunning panoramic view from one of Perseverance's key observation points. The rover took this photo after a long drive, and it presents a broad view of the landscape, showing off the rolling Martian terrain in all its vastness. Moreover, Ingenuity's video and audio of its fourth flight on April 30, 2021, provide both visual and auditory records of the flight. Perseverance was also spotted by Ingenuity during its 11th flight in August 2021, providing a unique aerial perspective of the rover, captured from above. In September 2021, another image from Ingenuity shows the Rochette Formation, a fascinating geological feature that caught the rover's attention. Ingenuity also captured the entry descent landing debris in its lens on April 19th, showcasing us the various remnants of the rover's landing sequence, including the parachute and backshell. Then there's a panoramic 360-degree view from Perseverance's landing site, showing a complete, stitched-together panorama from the rover's landing site, offering an immersive view of Mars as if standing right next to Perseverance. The most recent photos released by NASA show fascinating transits, as viewed from Mars, like the one taken on January 19, 2024, showing the moon Deimos passing in front of the Sun. Similarly, images from February 8, 2024, show the moon Phobos crossing the Martian sky, and an October 2023 image even captures Mercury's transit from Mars. Mars is in focus like never before. But why bother? And how important can a couple of pictures even be? Well, let's find out. The future of Mars exploration and colonization. Mars has captivated the human imagination for centuries. As the next frontier for space exploration, its potential for discovery and even colonization has inspired ambitious missions and futuristic ideas. While Mars exploration is still in its early stages, the developments in technology, international collaboration, and human ambition point to a future where humans could live and thrive on Mars. This journey is not only about reaching another planet, but also about the advancement of science, technology, and the human spirit itself. The future of Mars exploration and colonization holds both tremendous promise and considerable challenges. Over the last few decades, we have witnessed a remarkable evolution in our capabilities to explore distant planets. Robotic missions like NASA's Perseverance rover, the Ingenuity helicopter, and the Mars Sample Return mission have demonstrated vast improvements in robotics, AI, and remote sensing. In the coming years, we can expect further breakthroughs that will facilitate both the exploration and eventual colonization of Mars. Moreover, we're working on efficient space travel. Spacecraft like SpaceX's Starship, designed to carry large numbers of people and cargo to Mars, are at the forefront of this evolution. These advanced spacecraft will dramatically reduce travel times and costs, making it feasible to transport humans to Mars on a regular basis. Reusability, as demonstrated by SpaceX's Falcon rockets, will play a key role in making Mars exploration sustainable. Over time, spacecraft capable of producing fuel on Mars, such as through the conversion of local carbon dioxide into oxygen, will be pivotal in reducing reliance on Earth-based resources and lowering mission costs. Another area of advancement is autonomous robotics. Robotic systems will play an essential role in preparing Mars for human habitation, performing tasks like construction, resource extraction, and habitat building. These robots could work in parallel with astronauts, setting up infrastructure, establishing power systems, and even preparing the environment for life support. The use of AI to analyze data and make decisions in real time will also become an indispensable tool for long-term missions, allowing both robots and humans to work more efficiently and safely on the Martian surface. One of the most significant challenges of Mars colonization lies in creating a sustainable environment for humans to live. Unlike Earth, Mars has a thin atmosphere, low temperatures, and very little liquid water on the surface, which makes survival extremely difficult. However, scientists and engineers are developing various solutions to overcome these obstacles. Mars has only about 1% of Earth's atmospheric pressure and is constantly bombarded by harmful solar radiation and cosmic rays. To address this, future habitats may be built underground or within artificial domes that can shield astronauts from radiation. Additionally, technology will likely evolve to create self-sustaining life support systems capable of generating breathable air, managing waste, and providing safe drinking water. One promising avenue for long-term habitation is the use of local resources to create breathable atmospheres. The process of in situ resource utilization, or ISRU, could allow astronauts to extract water from the Martian soil and convert carbon dioxide into oxygen. Additionally, technologies like the Mars Oxygen ISRU experiment, or MOXIE, which extracts oxygen from the Martian atmosphere, are already paving the way for this. Establishing reliable oxygen production systems will be essential for both human health and the success of a Mars colony. Another challenge of Mars colonization is ensuring a reliable food supply. The potential for growing food on Mars has been explored through various experiments, including NASA's plant growth studies. By building greenhouses and using advanced hydroponic systems, future Martian settlers could cultivate food on the planet itself. Mars soil, though inhospitable, may also be treated to make it more suitable for agriculture. Furthermore, closed-loop ecosystems that recycle waste into nutrients could provide an ongoing, sustainable food source for colonists. Then there's the challenge of securing a constant power source. Solar power has already been successfully used by rovers and other robotic systems on Mars, but solar energy on the planet is weaker than on Earth due to the greater distance from the Sun and the planet's frequent dust storms. As a result, nuclear power may become a more viable long-term solution, providing a reliable and consistent source of energy. Once Mars colonists establish a base, the next step will be to explore its surface. Developing transportation systems that allow easy movement around the planet is essential. Rovers like Perseverance are just the beginning, and in the future, we may see larger, more versatile rovers capable of carrying humans and cargo across greater distances. These vehicles will need to be equipped with life support systems, enabling astronauts to travel far from their base without fear of running out of supplies. Spacecraft capable of landing, taking off, and operating on Mars will also be crucial for exploration and transporting people between Mars and Earth. Long-term missions to Mars present significant challenges to human health, both physically and mentally. Space radiation, muscle atrophy, Bone density loss and other physiological issues need to be addressed before humans can live on Mars for extended periods. Advances in medical technology, such as telemedicine, robotic surgery, and 3D printing of organs, could ensure that astronauts have access to necessary healthcare in a Mars environment. Equally important is the psychological aspect of living in isolation on Mars. With communication delays of up to 22 minutes one way, maintaining a sense of connection with Earth will be challenging. We must develop mechanisms to support mental health, such as virtual reality experiences, communication with loved ones, and leisure activities that mimic Earth-like environments. Building a sense of community and purpose among colonists will also be essential for maintaining morale. The future of Mars exploration and colonization will have to be a collective effort involving international space agencies, private companies, and research institutions. For instance, agencies like NASA, the European Space Agency, Roscosmos, and others will likely work together to develop the infrastructure needed for human exploration. SpaceX, Blue Origin, and other private companies have already made significant contributions to the development of reusable rockets and spacecraft, lowering the cost of space travel and opening up the possibility for commercial activities on Mars. Today, it's just pictures and videos. Tomorrow, Mars can be our second home, one step at a time. For now, we can look at these visuals with awe and wonder. Who knows, maybe one day we'll get to see the real thing. Looking ahead, the future of Mars exploration and colonization is bright, yet full of challenges. Humans may one day walk on Mars, build colonies, and begin to unlock the planet's secrets. While there are many hurdles to overcome, the rapid advancement of technology and human ingenuity gives us reason to believe that we are on the cusp of a new era in space exploration. Mars offers an opportunity to expand humanity's reach beyond Earth and create a sustainable, self-sufficient colony that could one day serve as a model for other planets. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.